There we go. Okay, let me get that for you. Between two sets of numbers. And sometimes a relation is a, what's this other word that starts with F? Function, good. So a relation is a function when every input is paired with just one output. So here are some examples of how functions might look. You might see a function in a table of values where every input has one output. When you're looking at a graph, what you're looking for is every x has one y. So you can see that this x does not have different y's, this x does not have different y's, and this x does not have different y's. When we do that thing called the vertical line test, that's what we're doing. We're looking to see if there's an x that has different y's. Here too, if you do the vertical line test, you can see every x has just one y. All right. Down here, these are examples that are not functions. And when it says why not, I want to know like specifically where do you see a problem down here. So that's your first task, and I'll maybe I can pass out your Starbursts while you do this. You're explaining why not for each of these three. Okay? Why are these not a function? Feel free to help your neighbors. All right. First one, raise your hand if you see the problem with the table of values. I see a few hands, and I appreciate all those hands. That's excellent. Daniela, what do you say? Yes, so the x is repeated here and here, right? And then Jasmine, when the x is repeated here and here, do they have the same output? They do? So when the x is 0, the y is 2, right? What happens the next time the x is 0? But it doesn't have 2, right? What does it have? It has a 4, right? So when x is 0, the y could be 2, or the y could be 4. And you're right, those are going to land on the same vertical line. So that is the problem here. You have the input 0 has two different outputs. So those are some good words to write. Does anybody think that they wrote it in a different way that also might be helpful to other people? Do you want to share yours off?
It was kind of the same as what Katie talked about.
Yeah.
Just noticing 0, 1, 0.
Excellent. Good. So you noticed the same thing. That's great. Yes. Okay, you can go ahead. Be quick though, okay? All right. Second one. Raise your hand if you can explain where the problem is. Why that one is not a function. I'm looking for a few hands. I see one hand. I'm looking for the second one. 2 hands. And what do you think?
The x's are the same.
Which x is the same? Is
The
it
ones that are on 0, 4, and 0, 2.
Oh, okay, right here. All right. So, in words, Anne said the x's are the same, and also I would add with different y's. And actually, notice it's actually the same set of data here and here. Not this one, but these first two are the same set of data. These points are just put right here. So, I'm going to be a little bit more specific, but still take Anne's idea. When the x is 0, there are 2 different y's. Now, did anybody also write it doesn't pass the vertical line test? Good. Jasmine wrote that. Anybody else? So that's another thing you could do. In Algebra 1, you may have learned about the vertical line test that says if you draw a vertical line and it crosses more than one point, it's not a function. So you could also write does not pass vertical line test. And if that were a test question, either of those answers would be sufficient. You could write either the first sentence or the second sentence. All right, third one, raise your hand if you know what the problem is. Why that's not a function. I see one hand. I'm looking for a few more. It's this one I'm asking about. Looking for a few more hands. Why is that third one not a function? See, 2 hands, 3 hands. Jacob, what are you thinking?
I don't think it passes the vertical line test.
All right, who agrees with Jacob it does not pass the vertical line test? Excellent, very good. Did anybody want to say it differently? You like that one? Okay, we can say it does not pass the vertical line test. Sure, yeah. So the vertical line test, if there's any place where you can draw a vertical line and it crosses more than one point, then it is not a function. So here, if I draw my vertical line, I can see it crosses here and here. So it does not pass the vertical line test. And remember, that test is telling us that there is an x value, such as 3, where there are 2 different y values. All right, so on the bottom, at a minimum, I want you to write yes or no under each one if they're functions. And if you have extra time, you can explain to me how you know underneath. All right, first one, yes or no? No, because of what number? The 1. Yeah, so 1, 3, and then 1, 1, that's the problem. No. Second one, yes or no? No. So here's my vertical line test. If I draw a vertical line, I can find a space that's going to cross more than once. How about the third one?
Yes.
Yeah, we didn't do any with points yet. Did you kind of look at the x values?
Yes.
Yeah, so here's an x, here's an x, here's an x. They're all different, so I agree with you that that's yes. There seemed to be a controversy about the last one. Does anybody want to explain why they think it is or it is not a function? Go ahead.
I think it's a function because it passes the vertical line test.
Okay, who agrees with Andrew? It's a function because it passes the vertical line test. Very good. So no matter where I draw this vertical line here, it will cross only one point. Remember, I'm not talking about if it crosses the axes. I'm talking about this function right here. Talking about this one. Okay? So no matter where I draw my vertical line, it will cross it only one time. So this is a yes, it is a function. So it's no, no, yes, yes. Who has a question before we turn the page? Alexis, can you put your computer away? Thanks. Did you finish the notes on this page, or do you need to catch up?
I'm not finished.
You're good? Okay, let's turn the page. All right, function notation. So function notation is just a fancy way of writing y equals. So instead of y equals, you'll see f of x equals. Sometimes you'll see g of x equals or h of x equals. And that's just because they're different functions, so they have different names. So if like f of x equals x squared, then I've already used up f of x, so I might want to say g of x equals x plus 1. So when they're different functions, sometimes they get different names. So I just gave you some other names they could be called. F of x is read as a function of x. F of x is read as a function of x, and it does not mean f times x. So a lot of times when you see a parentheses, that means multiply these two things. That is not what it means. Other times when you see parentheses, yes. When you see f parentheses x, it does not mean times. So keep that in your head. If you looked at that and you thought, oh, that's times, I get why, but now remember this. It does not mean f times x. Okay? To rewrite the equations in function notation, it's super easy. You take off the y and you put that f of x. Okay? So replace y with f of x. I did the first one, do the first one, and then go ahead and do the second one. All right, hopefully you got the second one okay. Instead of y, just put f of x. If you're having trouble seeing from where you are, feel free to move yourself up. I didn't fill the groups that were in the middle in that front one because I kind of trip over those desks a lot. I didn't want to trip on you. But you can feel free to move there for notes. All right, so evaluate the function for the given x values. So when you see this, f of 4, notice that the 4 is where the x is. You see that? The 4 is the x. I'm going to connect them to show you. The 4 is the x. So all I do is replace the x with 4. 3 times 4 minus 2, and I'm going to find the answer. And then I'm going to have you do the same thing for number 4. Number 5 is going to be done differently. You can work ahead if you have an idea, but I do warn you it's different. So work on 3 and 4, and feel free to think ahead about 5. Okay, so in this problem, we replace the x with 4. 3 times 4 is 12, minus 2 is 10. Over here, it's the same thing. The x is negative 3. And so I'm going to replace this x with negative 3. And I put parentheses on it to remind me not to just square the 3, but to square the negative 3. And let me show you what the difference is. There is actually a difference if I have parentheses or if I don't. So I've got this versus this. Okay? This is what we have. We're squaring negative 3. It means negative 3 times negative 3. And a negative times a negative is? Positive. Positive. Good. What this one means, it means two things. It means square the number and then make the answer negative. So it means first, square positive 3. The negative happens all the way over here, and then square positive 3. So 3 times 3 is 9, and then you stick a negative on it, and you get negative 9. So this is what we have. It's this one. We're squaring negative 3. All right? They love to give you that tricky problem on like SOLs and such. So negative 3 squared is going to give me 9. And then plus 2 is going to give me 11. All right, what questions do you have before we talk about number 5? Now in number 5, it's different. It says f of x equals 7. And you see how we have an f of x right here? So we're going to put the 7 for the entire f of x. It's not the x this time, it's the entire f of x. So it goes here, 7 equals 3x minus 2. And now we get to do a little algebra. So solving for x, what would be the first thing that we have to get rid of?
2.
Yeah. So the inverse of minus 2 is plus 2. That will cancel out, and I get 9 equals 3 times x. Jasmine, what happens next? Yeah, that's right. So the inverse of multiply by 3 is divide by 3. Divide by 3 on both sides. And what did everybody get? Nice. Very good. X equals 3. Who has a question? Okay. So also we can evaluate graphs. So let's take a look at this graph here. Ignore my blue, that was from the other side. X-intercepts are the points where we cross the x-axis. Y-intercepts are the points where we cross the y-axis. So here is my x-axis right here. X. Where's the y-axis? It's this one, right? It says f of x, but we know f of x is the same as y. So here's my y-axis, here's my x-axis. So my x-intercepts, notice I have them written as points. My x-intercept, the first one is over here. That's an x-intercept. Negative 0.5. Negative 0.5, comma what? What's the y value of that point? Let's look at the y-axis. Anne suggests 0. Yep, 0. So here we go. The y value is 0, so it's negative 0.5 comma 0. See if you can figure out the other x-intercept and then the y-intercept as a point. And then my y-intercept, instead of putting the 0 for the y, I should put the 0 for the what? X. So it's going to be 0, comma, what number does that look like to you? 6? Okay. I can't tell because I kind of wrote on top of mine, but I believe you at 6.
Because then it goes up by balls.
Okay. This grid is not beautiful, is it? Let me see if I can find the original to give you a better grid to look at for 0.2, 2.4, and 10. I bet you guys have done a decent job on it, but I like to look at it more clearly. Give me one sec. All right, so we said f of 0.2, 0.2 was here. And when we went up, we saw that the y value was 7. F of 2.4 was right here. And when we went over, we saw the y value was 1. And then f of what is 10? So this time the 10 is the y value. And when we went over, we saw that the x value was 1. Questions before we turn the page? Okay. All right. Domain and range, new subject. Raise your hand if you remember hearing these words from Algebra 1. Anybody? Domain and range? Okay, it's okay if you didn't. We're going to learn it. Does anybody remember which one is the x values? Domain, yeah. So domain is the x values, which means range is the y values. The best way I found to remember and keep those words straight is that they're both alphabetical. So x comes before y, domain comes before range, in case you're tempted to mix them up. It says in the table on the next page, copy the appropriate domain and range for each graph. So these are just examples. There are no problems to do right here. It says that the domain here is negative 2 comma 4, or negative 2 less than or equal to x less than or equal to 4. The range is negative 3 comma 0, or negative 3 less than or equal to y less than or equal to 0. I would like you, and you and your group can write the same thing or different things, it doesn't matter, but I want you to write a sentence about something that you notice, and then something that you wonder about domain and range by looking at these examples. All right, so down on the bottom here, this is all the things that you guys noticed and wondered. When I say the domain is negative 2 to 4, here's my negative 2, and here's my 4. So the x values go from negative 2 to 4. When I say my range is negative 3 to 0, here's my negative 3, and here's my 0. So my y values go from negative 3 to 0. Notice that it is always going to be smallest, comma biggest, never switched around. Smallest to biggest. Oops, it's kind of small. Here my domain starts at 2 and it goes to infinity. But for the range, this one keeps going down and this one keeps going up. So the down one is going down to negative infinity and the up one is going up to positive infinity. On the back is a matching. You're going to try to match the correct domain and range to the correct graph. Okay, so here's some graphs. Here are the domains and the ranges. So for each graph, you will choose a domain in interval notation and a domain in set notation that matches the X values. Okay? Work with your groups on that. Okay, first one, raise your hand if you want to share the domain, the X values. Go ahead, Elle.
One is less than or equal to
Good. And then 1 and 4. And on this 1 and 4, I would like you to make sure you guys have square brackets, because square brackets mean including the endpoints. Remember the endpoints are colored in? So 2 different ways to write the domain. Raise your hand if you have the range for this one. You have it? You want to share it? Anybody else get -3, 3? Michael got it, and Elle got it, and Ann got it, and Danielle, very good, and Andrew as well. All right, so -3, 3. Again with those square brackets, and then let's find the matching one down here. Oh, down here. So -3 less than or equal to y less than or equal to 3. Welcome back. All right. Anybody want to share the domain for the next one? This V shape. Ian, go ahead.
Negative infinity, comma infinity, and then x equals all real numbers.
All right. So the reason we have parentheses on negative infinity and infinity, remember from last class, is that you can't actually get to infinity. You can keep heading towards infinity, but you'll never get there. This is actually read x as an element of all real numbers, but if you say x equals all real numbers, I'll be fine with that. However, the range is not going to be all real numbers because it has a bottom point. What's our smallest y value? -4. So we're going to start at -4, and then we do go up to infinity. They might be coming down here. They're loud enough. We'll see.
My sister is friends with Drumline. She kept saying, "Can you hear them? Can you hear them?"
That's so funny.
Can we go out?
There's nowhere to go. Like, we would have to go all the way out there, and I'm not going there. I'm going to finish these notes up. So the range here would correspond with this one. Y is greater than or equal to -4. Doesn't sound like there's much to say. All right, number 3. Raise your hand if you want to share the domain. Who has the domain? I see 2 hands. Hey, Chase. Anybody else? All right. Daniela, what'd you get? Yes, another negative infinity, comma infinity, because it's going out to both sides. Very good. And so that will also correspond to x as an element of all real numbers.
So if it has something like with the infinity, does that also mean it's always going to be?
Yeah, anytime you have negative infinity to infinity, that pretty much describes all the numbers, right? So that's going to be all real numbers. Jasmine, did you get this one, the range? What'd you get? And what's the other part?
And then I got y equals, wait, y is greater than equal to 0.
Good. All right, this one was tricky because you look at this point here and you notice that this is the bottom point, but when you're looking at it, you're not thinking about the number 0, you're thinking about the number -4. But Jasmine's right, the y value here is actually 0, because if you look over here on the y-axis, it hits 0. So if you wrote -4 infinity, I totally see where you're coming from because that's the number you're looking at, but you actually want the y value there. So make that correction and make it 0 to infinity. Okay, who has a question so far? All right, last one before a break. Okay, so this one has arrows on the left side. So we would be starting all the way on the left side. What number is all the way on the left? Negative and 3, and then negative 4, and then negative 5, and negative what? Infinity, right. So negative infinity, and it keeps going to the right until we hit what number? 3 again. So x is less than or equal to what number? 3. For the range, you have this arrow here. It's going left, but it's also going just a little bit down. And you have this arrow here that's going left, but also a little bit up. So since we're going all the way down and all the way up, that would be what? Yeah. It is from negative infinity to positive infinity, and so y is an element of all real numbers. All right, that was a long set of notes. Even on just on the video, it was 25 minutes.